Today I'll be showing you guys not only how to swap between elevators and stairs by reading the actual blueprint information using your PCG graph, but also the ability to rotate your meshes and have it actually scale and properly position themselves inside of the hole that we've cut out for them. So that way, even if the pivot point is not in the center, it will go ahead and offset and position itself to fit perfectly in the hole that you want them to appear in. So without further ado, let's get right into it. To get started, I want to replace these trigger boxes that we have in the world that are just basic box collisions with actual blueprints that hold a box collision. That way, we can go ahead and add variables to it and control it as we need. So let's go ahead and right-click in our content browser, get ourselves a blueprint class of a type actor. And I'm going to call this BP underscore stairs and elevators. And then open it up. So this is going to be a relatively simple setup. What we're going to do is hit the add button and search for box collision, which basically recreates the same system we had before. But this time, instead of actually giving this a tag, I'm going to do it through variables, and I'm going to show you how to set those up so we can grab those from anything in the world. The first variable I'm going to add is elevator, and it's just going to be a type bool, and it's going to be exposed by hitting the eye icon here on the right. And basically, by default, it will be using stairs, but if you want the elevator version, then you just click the checkbox and you get the elevator. And I'll add one more here, and this is going to be the rotation. And the type is actually going to be integer, and it's also going to be exposed. Now, in our case, because of the way we have things set up, we can rotate in 90-degree increments. We can't really do a 45-degree setup with our configuration because it doesn't really make sense in this modular workflow. Because of that, we're going to be basically using 90-degree increments, and so they're always going to be integers, so I can go ahead and keep it an integer. So basically, we're going to look is take this number, and we're going to divide it by 90 and just basically get a 0, 1, 2, 3. So because of this, we can go ahead and keep it as an integer for our needs. But once you compile this, this should be good to go. So now if I go ahead and take it and drag it out here, just like I had in the hitbox, we can go ahead and scale it up. But of course, it doesn't actually do anything at the current moment. It doesn't understand anything. It just sees, hey, we have this hitbox. Great. Now what do I do with it? And for that, we need to open up our PCG graph and swap out our system to work with this instead of the trigger boxes we had before. So go ahead and open your PCG building graph. And basically, we need to go everywhere where we were cutting this out. For example, on the floors and ceilings right over here, we're doing get actor of data by tag stairs. You can see here in the detail panel, all world actors by tag stairs. But in this case, I don't want to do it by tag. I want to do it by class. Now, the easiest way to populate this is either through the dropdown, or what I like to do is just select it in the content browser and then hit this arrow right over here. This populates it with the class we want, and we make sure that it's the correct one. And we want to do that not only for the floors and ceilings, but we also want to do it for this difference down here in our interior walls and doors, because we also want those removed. So here in the get actor data, we also change that to by class and plug it in. And the last one we need is this stairs and elevator section, where we are grabbing the actor data and spawning the actual setup. So here again, change to by class and plug in the class. And as soon as I do that, you can see I have stairs now where this blueprint is, and I don't have it anymore where these two are. So I can go ahead and remove them already. Fantastic. So already we kind of have replaced our system with a blueprint. Now this is great, but now what happens if I want to rotate this? Let's say I want to be in this location, but I want the stairs, instead of going this way, maybe I want to go towards me or to the left. Well, at the current moment, if I was to rotate the stairs, let me show you what happens. I've gone ahead and added a transform points here with a 90-degree rotation. And you can see, well, the stairs have rotated, but they're also now offset here. Now, why is that? That is because the actual bounds location has moved effectively because we've rotated the stairs, and the stairs pivot, as you can see right here, is actually at the edge. So when we rotate it, of course, well, we rotate it and at this pivot. We don't rotate in the center. So it has multiple issues. And of course, to combat this, in our data asset, we're offsetting it in X, in -half length, and we're moving it down. We're also scaling it. And of course, all of this means that once we actually go ahead and rotate it, it is no longer in the right place. So we need to adjust the thing to be in the correct location at the correct scale, no matter the rotation that we specify. So to do that, we need to grab the information from the blueprint. Now, I've removed the transform points because that was just for the demonstration. And now we need to go ahead and grab the information that we're going to put into basically the stairs mode. let's control which one spawns stairs or elevators. And we need to do it based on a bool. Now, really quick, before I get started, we currently only have stairs here in our data asset. Let's get a new input here that is going to be our elevator. Navigate to your data assets folder and open up your PDA modular building. And here we can go ahead and duplicate stairs and just call this elevator. And now under your data asset, we now have an elevator field that we can go ahead and populate in here, and you can populate your elevator mesh right in here. Now, I'm doing this as stairs and elevators, but if you wanted to, you could really just make it version A stairs, version B stairs, etc. You could even have a bunch of them and choose between them. If they all share the same pivot point, it'll make it even easier for you. This is entirely configurable for your needs. I'm just showing you this way of doing it. Great, so now we have something that we can grab for both stairs and elevators. So let's go back to our PCG graph. So to get started, I'm going to grab our get actor data here. I'm going to just duplicate it down here. I'm going to just set it up here, and then I'm going to move it up above. But we need to get this, and we need to merge the points information that we got from it. So effectively, we have one version that if you hit A, you could see down here, we have separate information. We only have 1 point here. That's because we only have one of these. If I go ahead and duplicate it, let's say make this one smaller and just put it in a different location. Let's say right over here. We now have both of these and they're separated out. And when you sample the merge points one, you can see they're both together. So effectively, we need to actually get all the information we need from this blueprint. Now, how do we do that? We're going to need a loop node for this. So in our loops folder, let's go ahead and create a new PCG graph. I'm going to call this PCG_get variables. With it created, I'll go ahead and click and drag it right into our PCG graph and select create loop node, and then double click it to open it. For our input, I went ahead and created a point that is a loop that is required for the first slot. And for the second slot, it is just a normal point that is also required. And the output here is just a regular normal point. So now to be able to sample this, I'll go ahead and plug in our get actor data into our get actor data slot and our merge points into the merge data slot. So now I need to get the attributes from this point information. What I can do is use the get attribute set from index. Now what this does is it takes the attributes and only grabs the one from an index. So for example, the one from point 1, from point 2, etc. Now that's great, but we need to specify the index in here. To do that, we can do get loop index. So when it does the first point here, it will grab the first point's information because as you see here, we're plugging in the exact same information into both. So the first point here is the first index here. So get loop index goes into index. And now we need to plug our merge data into here, but it says pins are incompatible. Now I'm not sure why it says that because normally things can convert pretty easily. And there is a node to convert from points to attributes. Search for point to attribute, and you can find here point to attribute set. Go ahead and select it and plug it into get attribute from index. From here, we need to get access to the variables. To do that, we need to get property from object path. And this is where you specify the actual variable you want to grab from your blueprint. So in my case, I want to grab the variable elevator. So I'll plug an out into this in, and I'll duplicate it and plug the bottom one in there. And the bottom one I'll rename to rotation. Now you can see there's no errors because it has found something. If I was to mistype the property name, you could see we'll get an error saying it doesn't exist. So that's how you know if everything is typed incorrectly, there will be no errors here. Now before we continue further from this, we actually need to specify an output attribute name for both. For a rotation, so we know which rotation it is because we might have multiple things called rotation, I'll call it stair rotation. And elevator, which is going to be our basically selection between stairs and elevators, I'll call this stair elevator. So the elevator bool will transform into the stair elevator attribute, and the rotation variable will transform into the stair rotation attribute. So now we need to go ahead and add it to our get actor data. So from our point here, we'll go ahead and do a match and set attributes. And the out is going to go into our match data. And we'll duplicate it and we'll plug in the other one here as well. And then everything is going to go into the output. Now this is also where if you needed more variables, you can go ahead and just duplicate this and set it up the same way and reattach however many variables you would like for it to go through and have it all go ahead and attach them. Because now, if we go ahead and press A on this get variables, we will see that we have our points. It is still split up between the two because that's how we piped it in originally. And all the way on the right here, you will see stair elevator and stair rotation. Now you can see it's false and 0, and it's the same thing on the second one. But if we go ahead and select this one, for example, and turn on elevator, and make rotation, let's say 90, then we can see stair elevator has been turned to true and stair rotation is at 90. So it's already getting the information. So that's fantastic. So we're getting exactly what we want. Now we just need to swap it out for our stairs mode here, which was how we were getting that information before. So instead of this PCG get selection bounds, we can go ahead and double click it to open it. And then in the input mode, here we have attributes set stairs mode. I'll go ahead and open up our last index, which are stairs mode. And here, instead of attribute set, I'm going to change it to point. And I'm actually going to detach where this point goes to because it's no longer correct. We'll go ahead and reattach this output to B that goes between the two versions. But the main thing is we're no longer piping in a bool ourselves. So now our main graph, before I plug this in, I want to go ahead and merge the points because right now they're all separated out. So from here, I'll grab ourselves a merge points node and then plug that into stairs mode. And just like that, we have everything here all plugged in. So now let's go back to get selection bounds and let's set up this stairs mode. So I want those two variables to stay with the points forever. So to do that, we can go ahead and use a node called get attribute from point index. And we'll need two of them because we've added two variables here. Now, it wants an index, so I'll go ahead and specify an index here by opening both of these up and right-click and search get loop index. Just like we did before, we're going to grab just the index that we need from these. And just like we had here in the get variables, the actor data that it's looping on and this merge data is the same as this differences that we had and the stairs. So we know that it's always going to match up between the two. So now we can go ahead and add this information from here to our floor points. So I'll search for match and set attributes, and we'll need two of them. I'll plug them in here, and I'll plug it all the way through like so. The first one is going to go into match data, and the second one's going to the second match data. Now, we haven't specified what the input actually is for either one of these. And the first one is going to be our stair elevator, and the second one is going to be our stair rotation. Again, if you typed it in correctly, you will see no errors or warnings. What this has done is added this information to the points that we've using to spawn pretty much everything, and so we can access it later down the line. But the next thing we need to do is right over here. We actually spawn and scale the mesh based on what it is. Now, right now, we're doing it based off of this stairs model that we have specified from our data asset. Because as you see here, we have stairs, and that's what we're getting. But sometimes we want to grab the elevator, and so we need to swap between them based on that bool. So from this data asset, I'm going to go remove the connection here by pressing delete. And then I'm going to right-click and search for select and grab ourselves a select node. Now, keep in mind that if you plugged it in right now, it goes ahead and converts this. So don't plug it in immediately. Once you have everything plugged in, it will automatically convert it to this type, and you will not have this conversion. So leave it like this until you've plugged something in. So now we need to open it up, and this use input B is going to be based on this stair elevator setup. So I'll drag from here and plug it into use input B. And so when it is true, it's going to be an elevator. So that's going to go into B. So that means this right here, which is configured for stairs, goes into A. And then I'll duplicate it and grab ourselves a second one. This is going to be our elevator. Again, named exactly the same we had it in the data asset. And that is going to go into B. And then this, you can see the output has been converted to an attribute. And now we can plug that into data asset. And if I look here, you can see, well, we now have a set of stairs and a set of and an elevator. And if I uncheck elevator, it goes to stairs. And if I check it, it goes back between the two. But you can see, of course, we haven't configured yet the fact that the stairs shouldn't go up that last floor like our elevator node is. So let's go ahead and set that up. And that is for this output to be. From our stair elevator here, we can go ahead and pipe it all the way through. But what I'm going to do is just add a little reroute node here because it's the same one that plugs into use input B. And before I plug this in directly, I'm going to search for not Boolean to grab ourselves an attribute Boolean operation, not. Because we want the opposite for this. If you don't want to use this not, that is fine. You don't have to use it. If you plug in output to B and then go ahead and swap these two around. So we want ceiling on the bottom one and floor on the top one, just like this. And then you can go ahead and plug it in directly without the not. And then you can see when we have the elevator, it goes ahead and spawns it at the higher level. And once the stairs, it only goes up to the floor that we specified. And again, if I toggle the bool here, you can see it swaps between going up the extra level and not. So that's basically how you go ahead and add the variables from any blueprint class in your world and attach them to your PCG graph and read that information. Now, if you guys are enjoying the tutorial so far, I would love to hit the like button and consider subscribing for more awesome tutorials like this. Let's get back to it. So now how do we rotate this and then maintain all the information we need for this? By maintaining the position, maintaining the scale, etc. Basically, the way we're going to do it is once we rotate it, the height of it maintains the same. We don't need to touch that. But effectively, the x becomes the y, and the y becomes the x in terms of axes. So if, for example, you had a really wide thing, right, it becomes really tall now. But we still want to make it wide. But it has rotated, so the x becomes the y, and the y becomes the x. And so we need to create a new node that is going to go ahead and not only rotate it, but also scale it the opposite when it's in 90-degree increments. And if that doesn't make sense, don't worry, I'll guide you through it. So we're going to need a new loop for this. So I'm going to right click, go to PCG, and grab ourselves a PCG graph. And this is going to be our PCG rotate stairs. Over here in our stairs and elevator that we've been working in, we're going to drag it out right over here and create a loop node from it. And just like before, open it up. For our input, it is a point loop node that is required, and our output is just a point normal node. All we need to do really is use a transform points and then plug it all the way through to the output. And then we need to configure it. Now, right away, I'm going to uncheck uniform scale because I need to make sure that when I scale it, it doesn't take only one axis. And the other thing I'm going to do is select absolute scale. What absolute scale does is if your point was already scaled to 222 and then you applied 222 again, it would multiply that scale, so it would become 444. But instead, what I wanted to do is basically overwrite whatever was there as the scale with the new one. So that way we can take the original scale, flip it as we need, and then pipe it in and tell it, hey, just use the scale, don't also scale on top of what you already had. Let's start with the rotation. I'm going to drag out of the input and then get attribute from point index. And our input source is going to be our stair rotation. And this is why we added it here, so we can access to it later. And then from here, I need to right click and search for make rotator from angles, this top one here. Now I'll go ahead and plug this attribute into yaw, and then I need to plug both of these into rotation min and rotation max. And now we need to flip the actual scale of it depending if it's rotated by 90-degree increments. Now, how do we do that? We get ourselves another get attribute from point index from our input, and this is going to be our actual scale. So I can hit the plus button and select scale because we want to know what the scale of the point is. And then I need to know, basically, instead of 0 to 360, I need to go in 90-degree increments. So 0, 1, 2, 3. To do that, we can grab our attribute here, which is our stairs rotation, and then divide it by a create attribute node. And we set this create attribute node to 90. And by default, this divide node does not have force up to double checked, which means that the division only leaves the integer aspect of it. So if it was originally going to be 3.53, instead it's just going to be 3. If I was to check that, then we would get an actual float. But in our case, we want it to be an integer because we just want to switch on an integer based on what that input is. So from here, I'm going to right click and search for select, and we want select multi. This is the first time we're using this one. What we're going to do is selection mode being integer, and integer options, we want 0, we want 1, 2, and 3. Now keep in mind, if I set this to be the same input here, index 3 is 0 as well, you can see it doesn't appear. So you want to make sure you type in the values, and then you will see them pop up. So I'll open up this integer selection to reveal the actual settings here, and this divide will go into integer selection. So now how do we scale this? Well, when it's not rotated at all, we just want the scale to be the scale. In fact, if it's rotated 180 degrees, we don't need to change the scale at all. So I'll go ahead and plug it into 2 as well. Because again, 0 is 0, 1 is 90, 2 is 180, and 3 is 270 degrees. This is not set up to do negatives. Keep that in mind. You can, of course, set it up for using negatives. In my case, I'm just assuming that, hey, you're going to be rotated knowing that you need to do only positive values between 0 and 360 degrees. In fact, to make sure that this only happens between 0 and 360, in our actual stairs and elevators blueprint, I'm going to select our rotation, and I'm going to make the slider and value ranges between 0 and 360. This way, you cannot actually type in or input a value that is outside this range. So we will never accidentally have a negative value or a value way too high. So now how do we flip it for 90 and 180? Well, that is actually really simple to do. We take this attribute and we search for break to break vector attribute. And then we want to search for make vector attribute and change the output type to vector, which gives us X, Y, and Z. And basically our Z goes into Z, our X goes into Y, and our Y goes into X. And then this goes into input 1 and input 3. And then from here, we can plug this into scale min and scale max, and then close this up. So effectively, we're rotating by our rotation, and then depending on how many increments of 90 we do, we actually scale in different axes. So over here in our PCG building, right before the actual spawning of the stairs or elevators, I'm going to plug in this PCG rotate stairs and plug that all the way through. Now, when I do this, you can see there's a warning. Cannot find attribute property stair rotation on input 0. And you might be wondering, well, why is that? We did match and set attributes here. Well, in fact, when we did match and set attributes, we never specified an output attribute name. And I wanted to show you what happens when you forget it. If you were to try to use this down the line, it doesn't actually know it, even though you're specifying it. So inside the get selection bounds, we want to go ahead and specify this output name, and I'm just going to copy it and pass it all the way through exactly the same way it was called in both stair elevator and in the stair rotation. We now have it piped into both. And when I do that, you can see there's no warnings, there's no errors of any kind. It's a very easy thing to miss. So I want to show you what happens if you do, so you don't worry in case you see the warning pop up. So now we're here on the stairs, and you can see the rotation set to 0. What happens if we set it to 90? Well, that's odd. It didn't actually rotate it at all, but we set it up. Why doesn't it rotate? If we come here, we're doing a make rotator, and we have plugged into the rotation. That is absolutely fine. That's odd. If we hover over roll, it says pin is optional. We'll use the default if not connected, which is 0, and that's good. We don't want it to rotate. Well, this, for whatever reason, this pin is optional thing for the rotator is a lie. I mean, it's a bug, but basically you need to put something in there. So I'm going to right click and search for create attribute and then plug in 0 in both roll and pitch. When I do that, you can see it has rotated the actual mesh. Now the pivot we haven't offset yet. If I go ahead and put it back to 0, you can see it is rotating at 90 degrees. I put 180. It is all the way to the left here. 270. It is rotating around its pivot. Now we just need to offset it to put it back into the correct location, but everything is working here. And here, if I go ahead and set this to be an elevator, we can do the same thing, but this one is pivoted in the center. So when I rotate it, you can't even tell because it is a uniform mesh. But since this one we have offsets on, it is easy to tell. So how do we get around these offsets? Now, as always, the project files for this are going to be available on my Patreon, where you can join these wonderful people in supporting what I do. It really means a lot. If you'd like to join our community, the link to the Discord is down in the description as always. Thank you again to the patrons. Let's get back to it. So over here in our offset transforms, I'm going to open it from our stairs and elevator section. And here's where we're doing the changes to our transform points. Now, what that's doing is it's taking this offset and offsetting it because, of course, we need to compensate for the pivot being in the wrong location for the stairs. By wrong, I mean not in the center for convenience. So how does this work? Effectively, when you rotate the mesh 90 degrees, the X and the Y need to be flipped again. When you're doing 180 degrees, X and Y need to be mirrored, or just multiplied by -1 effectively. And then when you're doing 270 degrees, they need to be flipped and mirrored. And that will result in your stairs being in the correct location without actually needing to put in different offsets in your data asset. If that was a little bit confusing, don't worry. Let me show you how it's done. So here in our offset transforms, what I'm going to do is take this multiply transfer points and output and just drag it far to the right because we're going to need a lot more room. I'm also going to go to this rotate stairs that we just created. I'm going to take this make and break vector attribute. And I'm going to grab this integer selection that's already been set up. I'm going to copy it and I'm going to come here and paste it in. So right now we are taking our offset and we're just multiplying it by the amount we need to offset it by. But instead of plugging it all the way through, I'm going to unhook it from this multiply and plug it into the 0 slot here. Because by default, we just wanted to do what it was doing before, and this then can go into the multiply. Now it is complaining because it does not actually have anything in the integer selection here. So it says selected value is not a valid option. So just like we did here in the rotate stairs, I'm going to need the stair rotation with a divide by 90. I'll go ahead and copy that as well right in over here and plug that in from our input and take this divide and plug that into our integer selection. And you can see the error goes away because it now understands, okay, I know the input that's actually using. It is using 0 and we have that. So like I mentioned, for 0 and 180, it just needs to be mirrored. So I'm going to take our actual point from index here and then I'm going to multiply it using a create attribute as before into B. But instead of putting in -1 here, we don't want to do this. If we do this, the Z value is also going to be flipped, and we don't want the height adjusted at all. So for type, change it to vector, and I'm going to type in -1, -1, 1. So it only mirrors X and Y. And now we can take this and plug it into input 2, which is 180 degrees. Great. So now the 0 and 180 is done. So now let's do the 90-degree rotation, which just needs to flip the X and the Y. So from here, I'm going to plug in our N from the same location as the others, and this is going to be in input 1. And now for our last one, which is 270 degrees, it needs to again be multiplied by -1, -1, and 1. So I'll just duplicate it here, plug in from our make vector flipped into here, and plug that into our 3 node, and then we can pretty much close this up. And now if we take a look here, well, that looks correct. If I select it, it is a 270. If I do 0, it goes to the right, 90 degrees goes to the bottom, 180 goes to the left, and 270 goes to the top. And if I check on the elevator checkbox, we have it fit in exactly. You can see no matter which value I put in here, it goes ahead and adjusts. And you can tell it is rotating because if you look right here, there is no line here. But if I rotate it to 270 degrees, the line comes back. So it is also rotating this. So if this wasn't a perfectly uniform piece, you wouldn't need to worry. It goes ahead and adjusts it accordingly. So now if you want, you can have stairs in opposite direction or any way you want. And you can see if I go down below, the stairs continue until they reach the point where I've specified with the bounding box. So effectively now you can create a single elevator that spans the entire height or part of height of the entire apartment complex. And you can have stairs that go up and around however you'd like. And of course, you can swap out the meshes. You can make it something different. Now that we have a way of getting in between every floor in any manner we so choose, the next thing to do is the interiors. And if you didn't see, I released a video on how to put actual paintings and other things on walls, even when you only have just the floor points, which you can already get started with using to start your interiors for this place.